Okay, so for part C, it says the lines have a unique point of intersection when A is not equal to K. Find the value of K and find the coordinates of the point A in terms of small a. Okay, so where do two lines intersect? When they're equal. And when they're equal is when the x coordinates are equal, when the y coordinates are equal, and when the z coordinates are equal. Remember, the x coordinates of this line, guys, are 0 plus ta, if you like, or just ta, 1 plus ta, or sorry, 1 plus 1t, or 1 plus t, and 2 minus t, 2 minus t. That's the coordinates, the x coordinate, y coordinate, and z coordinate in terms of t. The x coordinate, y coordinate, and z coordinate of L, well, this is L1, are minus 1 plus 2 lambda, 0 plus lambda, which is just lambda, and 3 minus lambda. So to find the point of intersection, TA must equal minus 1 plus 2 lambda, because that's the x coordinate. So I'll write that down first. TA equals minus 1 plus 2 lambda. Then 1 plus t must equal lambda. The y coordinate must equal the y coordinate. 2 minus t must equal 3 minus lambda. Okay, so now we have a system of linear equations. The a, guys, is just a constant because we're trying to find the point of intersection in terms of a. So don't worry about the a. There's only two variables here. It's lambda and t. So you can solve this the way you'd solve just two linear equations or simultaneous equations. I'm going to do it using substitution. The best thing to start with is this one here, guys, because we have 1 plus t equals lambda, so I have the lambda in terms of 1 plus t. Now the problem is I'd like to just go straight to this line, but this won't work because the t's and the lambdas will just cancel each other out, so I can't use this equation, and I want it in terms of a anyway, so I'm going to have to go into this line here. So I'm going to substitute this lambda, 1 plus t, into here. So I have TA equals minus 1 plus 2 times 1 plus t. Now I have removed lambda completely, and I just have an equation in terms of t, so I just need to find t. So let's multiply this out. TA equals minus 1 plus 2 plus 2t. I will say, well, okay, let's leave that there. Let's do this. TA minus 2t equals 1. So I've subtract the 2t here, and minus 1 plus 2 is 1. Take out the t, a minus 2 equals 1. So t is equal to 1 over a minus 2. But what can't a be? Well, you can think of it here if you want. Because we're trying to find k, we're trying to find the value of a, or the value that a cannot be. Now let's think about it. If a was 2, if I put in 2 there, then I'm going to have 0 times t equals 1, which is 0 equals 1. Does that make any sense? No, definitely not. So a cannot equal 2. Another way to think of it is t is equal to 1 over a minus 2. And we know we can't divide by 0, so a cannot equal 2. So I'm going to write that down. A cannot equal 2. Therefore k equals 2. So that's the first part. Find k. It's the value of a that, or the value that a cannot be. And because of this, it's 2. Okay, then it says find the coordinates of the point of intersection of a in terms of little a. So I have t, so I don't even need to find lambda, guys. You could find lambda using this and then sub it in there, but you don't even need to do that because you have t, and the point of intersection will be, well, this is all the points on the line, and the point of intersection will be this point when t is 1 over a minus 2, because that's what we found t by solving these equations, which gave us the point of intersection. So essentially, the point of intersection is TA. So the x coordinate is t times a, which is a times this, because this is t. So it's a over a minus 2. So let me just repeat what I've done there. The x coordinate is t times a. T is 1 over a minus 2, so it's 1 over a minus 2 times a, which is a over a minus 2. The y coordinate is 1 plus t, so it's just 1 plus t, which is 1 over a minus 2. And the z coordinate is 2 minus t, which is 2 minus 1 over a minus 2. You could write these two as a single fraction if you wanted to, but it doesn't say you have to. It just says find the coordinates of the point A in terms of A. That's what I have done. That's the final answer.